In the last video, I explained to you the Q learning update rule. Now we are moving slowly towards our goal. We want to build a trading strategy. For that, we will build a deep Q learning network, DQN. That was developed by DeepMind to play Atari games with astonishingly high win rate like 95%, 94%. Now, when I was a child, I was in the school. I loved to play tic tac toe. Must have played tic tac toe. Just a piece of paper. You have three rows, three columns. Your friend makes a zero, and you then make an X. And ultimately, when if you have a zero, full row, full diagonal, or full column, you win the game. You have to stop the other player by making sure that doesn't succeed in getting a full row, full diagonal, full column. I came across this article, very good article written by someone, he's not given his name. So I have just copied this code. This is not my code. And in the link below the video, I'll give the link to that article and you can copy this code. But you should go through this code because that man has really very beautiful code. And going through this code will help you learn Python and especially NumPy. NumPy is a very powerful library that is the backbone of machine learning, deep learning, and reinforcement learning in Python. Basically, it's the backbone of AI. NumPy is the reason that Python succeeded as a deep learning language. So you should know how to work in NumPy, how to manipulate things. NumPy basically works with matrices, multi-dimensional matrices. I don't call them tensors, but I'll call them multi-dimensional matrices. So this is first we import NumPy as NP. You can copy this code from the link below this video and then run this code on your computer, and you should go through each line of the code and try to understand it because it will help you when we go to the next step. In our course will be building a deep neural network. For that, I will have to again understand few concepts, and ultimately then we'll build a DQ and DQ network that will train our trading strategy. So Tic Tac Toe is a game, and board games have been very popular in developing reinforcement learning, chess and Go. You know this that now reinforcement learning can successfully beat the world champions in chess and Go. But we're not going to go to chess and Go because they are far more complicated than coding tic tac toe. Tic tac toe is a simple thing. So this is the tic tac toe. First, all these there are three rows, three columns, and first they are empty. Players, one player is X, other player is 0. Number of players, just length of this player that is narrators, it will be 2. Q is a dictionary. These are Q values. We can print this. You can try it. Learning rate, I've explained in the previous video that we have a learning rate, how fast we want to learn. Discount factor, I've told you how fast we want to discount future rewards. Exploration rate is 0.5. Now there is something known as exploration versus exploitation in reinforcement learning. Exploration versus exploitation is that at each step the algorithm decides whether to use the existing Q value or means the maximum to use that action that has the maximum Q value, or take a random action and again calculate the Q value. So this is always a decision. So exploration rate 0.5 means half the time we will be using the existing calculated max Q value of action, or half of the time will be taking random action. And the number of episodes is 10,000. Then board to string, you go to this thing, action is any cell selected from the board, right? You should know the concept of a tuple. Tuple is just an ordered numbers. Now we define is game over. So for row in board, you see set row is 1 and row is equal to not equal to this dash return. This is a tuple true row. Python is beautiful because you can combine different type of variables in a tuple, unlike other languages. So if you go through this code, check columns, see board T, you know how to work with numpy, check diagonals. I've told you that tic tac toe, either you win the row, same X or 0, or column or diagonals, and check diagonals. So it will go through this code. So is game over? Then choose action. I've told you exploration is 0.5. So if random dot uniform 01 is exploration or state not in queue. So go through this code and run this code, and you will see that you learn a lot. This is a simple queue learning. There is no neural network in it. The simple updating of queue learning. We play 10,000 games, and after that 10,000 games, it has got something like 88% win rate, right? So go through this code, run it on your computer. This will, you'll learn a lot of things that will help us in our building and building the trading strategy with a deep queue network. Okay, you can copy the code, and I have given the link below the video.